In this video, I want to discuss a little bit of the nomenclature of the family of aldehydes and ketones. It is important to remember the same rules that we have applied for the family of alkanes will be used in here. When we change from the family of alkanes to the family of alkenes, we replace the suffix to ene. When it was an alcohol, we use the OL. And now for the family of ketones, that will be the ONE. However, when it comes to the family of aldehydes, it will be the beginning part of the word aldehyde that will be used as a suffix. We will use the rest using the parent, which is the long hydrocarbon chain with the prefixes meth, eth, prop, but, pent, etc., and also the locant to state what is the position of the carbonyl for the family of ketones. When it is in a family of aldehydes, the carbon that is the carbonyl will always be carbon number 1. Let's work some examples. The first thing is we have the family of aldehydes because attached to the carbonyl we have one hydrogen in all of these cases. We have 3 carbons long, that will be prop. This one is 1, 2, 3, 4 carbons is a but. This one is a 1, 2, 3, 4, 5 carbons, and so on. We have only one of them with a branch, that will be a methyl group. The next thing is we need to number the carbons. In all cases, carbon number 1 is where we have the carbon-oxygen double bond, and the substances will be named as an alkanal. We have butanal, propanal, pentanal, hexanal. However, this one has a methyl group on carbon number 5. So we need to find the locant for the position of the substituent methyl group. Repeating, this is propanal because it's 3 carbons long, butanal 4 carbons long, pentanal, hexanal, and this one 5-methyl hexanal. This substance is an alpha-beta, carbon number 2 and 3, unsaturated aldehyde, which means it has 2 functional groups. It is a 2-hexene and it also is a 1-hexanal. The name of this substance is 2-hexenal. The next one is an aldehyde with an alcohol group on carbon number 5. This group will be named as a hydroxy group. The name of this substance is 5-hydroxyhexanal. When a carbonyl and a hydroxyl group are present within the same molecule, the carbonyl will always take the smaller number when labeling the carbons. This molecule contains an aldehyde group and also an ether group. The name of this substance is 5-methoxyhexanal. Recall that we formed the names of the alkyl substituents from the parent alkane. For example, from methane we name methyl. Now we need to include the oxygen from methyl, methoxy. So the name of the substance is 5-methoxyhexanal. The next substance is an aldehyde, and it is also a primary amine. This is a primary amine because the nitrogen is attached to 1 carbon and is also an aldehyde. The name of the substance will be a substituted aldehyde, and this substituent will be named an amino group. It is 8 carbons long, therefore it is an octanal, and it has an amino group on position number 5 then it is a 5-amino octanol. Observe that the carbon number 1 is not part of the name in this octanol and is not in any of these different substances. Aldehydes, you don't need to state the position of the carbonyl because it is always carbon number 1. Now we look at some aldehydes that are aromatic. The first one is benzaldehyde that does not have any substituents. The second one is when we have a methyl group which is 4 carbons apart from the carbon that is bonded to the carbonyl. It can be named in 2 different ways as 4-methylbenzaldehyde or parabenzaldehyde. In similar way, we also have 3-methylbenzaldehyde. In this case, we need to always count and label the carbons, giving the smaller number to the substituent. If I start in this route, this will be carbon number 1, 2, 3, 4, 5, rather than 1, 2, 3. So this one is 3-methylbenzaldehyde or meta-benzaldehyde. Now I want to practice a little bit of the nomenclature of ketones. It's very simple. You need to find the longest hydrocarbon chain that contains the carbonyl group, making sure that that is taking the smallest possible number, and you will name it as an alkanone. That means you're going to drop the E from the alkene and put the ONE ending, stating the position where it is a carbon-oxygen double bond. The name of this substance will be 2-pentanone. It is named as an alkanone. Here we have 2 different hexanones, one with the carbonyl in position number 2 and the second one with the carbonyl on position number 3. The name of these substances are ending as hexanone, and the only difference will be what is the locant, what is the position of the carbonyl. This is 2-hexanone, and this one is a 3-hexanone. Observe that when labeling the carbons, we always start by the end that is closer to the carbonyl. So this is carbon number 1 closer to the carbonyl. And if I start on this one on that side, that will take carbon number 1, 2, 3, 4. So it's important to label the carbons always at the end that is nearer to the carbonyl. Now we need to name a cyclic one. This is also a hexanone, but it's in the cyclic form. Therefore, the name of this one will be cyclohexanone. Observe that we are not including the position of the carbon-oxygen double bond because it is understood that this is carbon number 1. The next one is a ketone and is also an alkene. It is a ketone on carbon number 2 and is an alkene on carbon number 4. The name of this substance will be a 2-heptanone and is also a 4-heptene. We need to combine those numbers and the name, and it will be a splitted name for the substance. The name of this substance is a 4-heptene 2-on. It is 7 carbons long, so it is a 4-heptene and the 2-on to establish the position of the carbonyl. Again, this is a 2-heptanone, but it includes a carbon-carbon double bond on position number 4. So we split 4-hep because it's 7 carbons, in because it's an alkene, 2-on because it is a ketone. This is a more complex ketone because it includes an aromatic benzene ring and also an aliphatic side. but it's so well known with the common name that IUPAC accepts the common name in all catalogs and in any research paper. You will find the name of the substance as the common name. The two possible names are methyl, phenol, ketone, or acetone, phenone. We did not include a number in the name of cyclohexanone. However, when we have substituents in the ring, we need to label the carbons beginning by carbon number 1, that is the carbonyl, to be used as a reference point. The name of this substance is 2-methyl cyclohexanone. It has a methyl group on carbon number 2, therefore it's 2-methyl cyclohexane because it is a 6-member ring, hexanone because it has an oxygen, but the carbon number 1 that includes the oxygen carbon double bond is not included in the name. This cyclohexanone has two substituents. We understand that this is carbon number 1, and we need to make a decision of which one will be carbon number 2. If I go in this direction, I find an ethyl group, and if I go in this direction, I will have a methyl group. I will need to go in the route that will give the smaller number to the ethyl because ethyl comes first in the alphabetical order. Now I know that I have a ethyl on carbon number 3 and a methyl on carbon number 5. The name of this substance is a 3-ethyl 5-methyl cyclohexanone. And as usual, the last alkyl group will go together with the rest of the name of the molecule without the inclusion of a number 1 for the ketone group.